Good afternoon, everyone. Welcome back. Welcome in the today's session, and I welcome all the students who are preparing for their exams based upon the general science. Okay, so guys, first of all, just do like and share this video link among all your friends, so that your friends can also get the benefit of our classes. And here we are going to start the new session and new video on your junior code assistant batch. Okay, so yesterday in the last class we have started the laws of motion, and we have gone through the first law of motion, law of inertia, and the second law of motion. Also I have explained linear momentum and then the law of conservation of linear momentum. Today we will go through the law of conservation of linear momentum. Yesterday we have seen that rate of change of linear momentum is equal to the applied force on the body, and if we apply a force on the body, then how the linear momentum of the body is changed. Suppose that if a body is moving with some velocity, then obviously it would have some mass. It means that this moving body would have some momentum also. If we apply a force on the body, then obviously the body will accelerate, and the body will accelerate, it means the velocity will change. If the velocity will change, it means the linear momentum will change, and then after some time you will have the different value of linear momentum. And in this case we can say that there is some amount of change of linear momentum. And suppose that this change in linear momentum takes a time delta t, then we can also calculate the value of the change in linear momentum in unit time, and that is known as the rate of change of linear momentum, and that was equal to the applied force on the body. And this is a very important result as a viewpoint of your exam. Okay, so again, good afternoon Priyanka, good afternoon Priyanka Meena, good afternoon. Okay, so let's continue the law of conservation of linear momentum. What is the law of conservation of linear momentum? Friends, when we talk about the conservation means to save something. If a body remains the same till a long period of time without any change, it means the body has been conserved. Okay, in the similar way, if a physical quantity or a amount of a physical quantity that is conserved for the some time, then we can say that this physical quantity value is constant. It means due to any reason this quantity is conserved. Here we will talk about the linear momentum conservation. It means the linear momentum of the body will remain conserved for a time period. Okay, but how does this happen? We will discuss it because this is a very important phenomena, this is a very important concept in physics. Okay, so oh, law of conservation of linear momentum. Law of conservation of linear momentum. Okay, when we talk about the change in linear momentum, suppose that, recall those lines I have already explained in the previous lecture. We all know that force applied this is equal to delta p upon delta t. external force applied, or we can say that force applied, delta p upon delta t. Delta p means the change in linear momentum. It means here we can say that p2 minus p1 upon delta t. p2 minus p1 upon delta t. So here f, it means suppose that if the force, if we do not apply any force on the moving body, suppose that if the external force is equal to 0, then what will happen? Then 0 will be equal to, then the 0 will be equal to p2 minus p1, p2 minus p1 upon delta t, upon delta t. It means p2 minus p1, p2 minus p1, this will be equal to 0. It means p2 will be equal to p1. Actually here we can see that p2 is the final linear momentum of the body, p1 is the initial linear momentum of the body. Like this, suppose that this body is moving with velocity v1 and the mass is m. Suppose that after some time the mass of the body remains constant but the velocity changes and this becomes equal to v2. So the linear momentum of the body will be equal to p1, that will be equal to m into v1, and here the linear momentum, final linear momentum, will be equal to m into v2. Okay, and suppose that we are talking about here if the external force applied is equal to 0, suppose that if we do not apply any force on this body, if we do not apply any force on this body, neither in the direction of the moving, neither in the direction of motion, or neither in the direction of opposite to the motion. Okay, so there is no external force in the direction of motion or opposite to the direction of motion. Okay, in this case we will write it as f is equal to 0, p2 minus p1 upon delta t. So the p2 minus p1 will be equal to 0. Here p2 is equal to p1. It means the final linear momentum is equal to the initial linear momentum. Here we can say that final linear momentum is equal to initial linear momentum. Okay, if this condition holds true, that the final value of linear momentum is equal to the initial value of linear momentum, it means there is no change, in the linear momentum. ठीक है ना? It means there is no change in the linear momentum. If there is no change in linear momentum, it means the linear momentum is conserved. No change in linear momentum. Hence we can say that hence we can say that linear momentum is conserved. Linear momentum is conserved. Okay, so this is the law of conservation of linear momentum. What will be the statement? If there is no external force applied on the body, then the linear momentum of the body will remain conserved. Okay, we will write it as if no external force applied on the body, no external force is applied on the body, the linear momentum of the body linear momentum of the body will remain conserved. Linear momentum of the body will remain conserved. It means the value of the linear momentum will not change. And the very easy and the very common example we can see that suppose that a ball has been placed on the icy surface. Icy surface means where the frictional force is zero. Okay. And suppose that you just pushed that ball initially and the ball started moving with velocity something 2 meters per second. Okay. Now the ball is moving with velocity 2 meters per second, and observe this ball, that the forces acting upon on this ball. Actually, there must be a frictional force between the surface of ball and the icy surface. But since the ice is very smooth, that's why the frictional force is completely absent between the ball and the surface. That's why there is no frictional force, and neither me nor any other person is applying the force on the ball so that it can be stopped or it can be accelerated. No, completely no. Okay, there is no external force on the ball right now, so this ball will keep on moving with the same velocity for a long time. It means if the value of the velocity of the ball at the present time is 2 meters per second, it means after 1 hour it will also be equal to the 2 meters per second, but the distance traveled by the ball will be very large, because after 1 hour or 2 hour it will it will change its position from here to another position, because this is just moving on the ball. Okay, and the ball will slide on the surface because there is no friction force. That's why it cannot move like this. Okay, so it will just slip. Okay, so doesn't matter that whether it is slipping on the surface or moving on the surface like cycle or any other or any other thing. Okay, but we will have to conclude this concept here, and we have gone through the law of conservation of angular momentum. Linear momentum. Okay, so this is one of the very easy, very common example, that if a ball is moving on the icy surface, the velocity of the ball will remain constant for a long time. That's why if the velocity of the ball will remain constant, it means the mass, the product of mass and velocity will also remain constant. Okay. And hence we can say that the linear momentum of the ball will remain conserved. Okay, so you guys, have you any doubt? If is there any doubt remaining, then you can ask any question regarding this topic, because I'm just moving ahead now. So please tell me if there is any doubt. You guys are just watching this video lecture right now, and I'm teaching here. My name is Kumar Ravi and I teach physics. Okay, is there any doubt? Please, you may ask. Please tell me the name of the students who are right now watching. Please tell me your name and city. Where are you sitting at right now? So that I can also guess that where my lectures are going day by day. Okay. Please tell me your name and city. Guys, please tell me your name and city. City means district name. Okay. Anyone, please do like this session and share this session among your friends who are from the English medium background and just want to prepare for their government jobs exams in the English medium. Please tell me your name and city so that I can get your name and city name. City, or it means district name. Okay. So this was the law of conservation of linear momentum. Now, We will move to another example of law of conservation of linear momentum. Suppose that here we are going to study an example, firing a bullet from a gun. Firing a bullet from gun. So this is a gun. This is a gun. Okay. So this is a gun, and suppose that this is the bullet inside the gun. Okay. Now, and this is the gun, but now the bullet has been fired by the gun, and suppose that the ball has been fired with the velocity v. Okay, the mass of the ball is equal to small m. The mass of the gun is capital M, and suppose that the velocity of the gun is capital V. Suppose that the velocity of the gun is capital V. Okay. Suppose that the velocity of the gun is capital V. Initially, the gun was at the state of rest. Okay. Bullet has been fired. Now the bullet has been fired. Okay. Suppose that when the bullet is fired by the gun, it means you will have to trigger. You will have to push that trigger, and when you push this trigger, the bullet will come out from the gun. But triggering a gun is not considered as a external force. Applying the force on the trigger so that the bullet can be fired, this force application cannot be considered as an external force. External force can only be considered in case of when the whole body changes its position when you apply the force. Suppose that this mobile phone, right now this mobile phone has been placed on my palm. If we apply some force, then this mobile phone just displaces from its original position to new position. Okay. In that case, we can say that, okay, in that case we can say that this is a external force. Okay, but if we deform this mobile phone by applying some force, then it cannot change the position of this mobile phone. Okay, that's why this force will not be considered as a external force. So right now you are just deforming by applying some force on the trigger. Okay, so there is no external force. So this is now. Okay, so here we can say that F external is equal to 0. Suppose that this is the value of the external force. Now, and suppose that initially the momentum, the mass of the gun is capital M, mass of the bullet is small m. Okay, so the complete linear momentum, that will be equal to capital M plus small m multiplied by 0, and the capital P will be equal to 0. Okay, capital P will be equal to 0. Capital P will be equal to 0. Suppose that capital P will be equal to 0. Now, okay, suppose that the linear momentum of the gun, this will be equal to P1. P1 will be equal to capital M into capital V. Capital M into capital V. Okay, and this is small p2 will be equal to small m into small v. Okay, p2 will be equal to small m into small v. Okay, so the total linear momentum, the net linear momentum p will be equal to p1 plus p2. Okay, so because this condition will hold true, because we know that f external is equal to 0. When the f external is equal to 0, it means the p initial is equal to p final. Okay, p initial, this is equal to itna, this is p initial. Okay, and this is equal to 0. P initial, this is equal to 0. P final will be equal to p1 plus p2. So p1 plus p2. Hence we can say that p1, this will be equal to minus p2. Here we can say that we can see that, sorry, here we can see that there is a negative sign. Okay, this negative sign shows that the direction of p1 is opposite to the direction of p2. This negative sign shows that the direction of p1 is opposite to the direction of p2. Okay, it means we have already mentioned that the after firing the bullet, this gun will move in the forward direction, or it means in the direction of motion of gun also, motion of bullet. But it's not true. Actually the gun will move just behind, or we can say that just opposite to the direction of bullet. Okay, so this will be the correct answer. Okay, so this will be the wrong, because this negative sign is showing that the motion of the gun will be opposite to the firing, opposite to the direction of motion of this bullet. Okay, so this holds true. So we can say that p1, mod of p1, this will be equal to mod of p2. Mod means the magnitude of p1 will be equal to magnitude of p2. It means only values will be equal, but the negative sign means this gun will move just opposite to the direction of motion of bullet. Okay, but the magnitudes, it means the values will be equal. It means p1 will be equal to capital M into capital V. This will be equal to small m into small v. So this is the formula which will hold true. For the gun. Okay, it means, so this is the momentum of gun, and this is the momentum of bullet. Okay, so this will hold true. So suppose that if you get any question in the exam, then obviously it will depend upon this formula. Okay, suppose that few years ago, when I was teaching in a batch in Mukherjee Nagar, offline batch, I just given an example in the class that a bullet of mass 20 grams was fired from a gun of 2 kilograms with the velocity 200 meters per second. Then calculate the recoil velocity of gun. You can't believe that the same question was asked in the same year in SSC CHSL examination. It was in 2017. Those students who were present in my class and who are knowing that this formula will hold true in this case, because if you get any question relating gun and bullet and firing of bullet, then obviously this formula will be applied and you will get your desired answer. Okay, so just write down, and now just see one thing. Suppose that, so here we can see that the value of p1 and p2 are equal. The values of p1 and p2 are equal, but these are in opposite directions. Okay, now just listen one thing. Suppose that Suppose that this is your gun and this is your bullet, and suppose that in this direction, linear momentum, is like this. This is m into capital V, and the linear momentum of this bullet is equal to like this. This is small m into small v. Suppose that if we divide both of these quantities, by delta t, if we divide both of these quantities by delta t, it means here we can see that this quantity mv upon delta t, this is nothing but equivalent to the force. This is momentum, this is time. Momentum upon time is always equal to force, and this is momentum upon time, this is always equal to force. Since mv is equal to mv, delta t equal to delta t, and hence we can say that this is a force and this is also a force. But what kind of forces? The names of these forces are like this. This is action force, this is action force, okay, and this is reaction force, and this is reaction force, and this is reaction force, okay. So this is action and this is reaction force. So here we can see that the evolution of third law of motion, and this is the point where the third law of motion is actually generated, is produced, is born, okay. So that's why the third law of motion is based upon the law of conservation of linear momentum. According to Newton's third law of motion, if a body applies a force on the first body, then the first body also applies equal and opposite force on the second body. It means every action force has equal and opposite reaction, and this is the third law of motion, and you all know this. There are many examples based upon Newton's third law of motion. Like, suppose that if you swim in the water, then obviously you apply some force on the water towards the backward direction of your motion. You want to swim. You apply some force in this direction, then obviously you will get some reaction from the water in the forward direction. Then you will move in the forward direction. This is just because of a reaction force. Because you have applied an action force, you will receive a reaction force that will push you in the forward direction. Similarly, in the case of rocket, when the hot gases of rocket, they just apply force in the backward direction, downward direction, like this. Rocket receives a huge amount of force in the upward direction, like this. Like this. If you walk on the road, then you just push the earth in the backward direction. You get the equal and opposite force on your body in the forward direction. That's why you are able to move on earth. Otherwise, suppose that if I ask you to move on the icy surface, it means a surface which is very, very smooth, friction is absent. You try to apply the force in the backward direction, but actually no force has been applied by your feet in the backward direction. That's why you will not receive any reaction force in the opposite direction. And due to this, you are not able to move on the icy surface or a very smooth, 100% smooth surface. That's why it is very difficult to move on the 100% smooth surface. And this is the reason that we also call that friction is necessary. Because if friction will become absent, then nobody able to move on the roads. Nobody will be able to swim. Okay. Helicopters will stop flying just because those wings who will apply the force on the gases in the backward direction but will not get back the equal and opposite reaction, so that they can also lift upwards. Okay, so this is the concept behind the Newton's third law of motion. So please write down this concept, and I will solve an example, a numerical example. Okay, you will get in your exam, I'm sure. Please write it down. And please tell me the name and city. Okay, Yujna from Mumbai. Okay, Yujna. Are you getting my concepts I am explaining here? If you have any doubt, then you can raise your doubt here and I will try my best to solve your problem. Okay. So, this is the example of bullet and gun. Bullet and gun. Bullet and gun. Bullet and gun. Okay, now suppose that a numerical problem. I'm going to give you a numerical problem and you will have to solve that question. Okay, and I will check that whether you are able to solve this question or not. A bullet of 20 grams is fired from a gun of 2 kg. ठीक है, from a gun of 2 kg with velocity with velocity 200 meters per second. 200 meters per second. Okay, if calculate the simply calculate the recoil velocity. Calculate the recoil velocity of gun. Calculate the recoil velocity of gun. Okay, so what is the recoil velocity actually? Most of the people, they just don't know what is the recoil velocity. Recoil velocity can be defined as the velocity by which the bullet, the gun comes back when you fire a bullet. Okay, tell me what will be the correct answer. So, we all know that when a bullet is fired from a gun, then the law of conservation of linear momentum, the momentums of both the things, means the bullet and the gun, will always be equal. Okay, we have already gone through the concept of this, that the momentum of bullet and this will be equal to momentum of gun. Okay, so bullet, this will be equal to small mv and this will be equal to capital M into capital V. Okay, so mass M, bullet, it means 20 grams, it means 20 upon 1000 into V. V means 200 meters per second. 200 meters per second. Capital M means 2 kilograms. 2 kilograms into V. Okay, so now here you can see that 200 into 5, and this will be equal to 1000, and 5 1 ja 5, 5 4 ja 20. Now the 4 will be equal to 2 into v, 2 into v. Okay, so v will be equal to 4 upon 2, and this will be equal to 2 meters per second. Okay, it means the recoil velocity of gun will be equal to recoil velocity of gun will be equal to 2 meters per second. It means the gun will come back with 2 meters per second. Okay, gun will come back with 2 meters per second. Now, okay, please write down. Do like this session and share among all your friends so that they can also get the benefit of this session. Okay, guys. So write down. I have explained the each and every point of Newton's first and second and third law of motion. Now I will take some examples of Newton's third law of motion, as well as I will write the definition of Newton's third law of motion, or you can say that the statement of the Newton's third law of motion. Even though this is very simple, but still you will have to write in your notes. Okay. So Newton's third law of motion. Newton's third law of motion. Newton's third law of motion. Dear friends, when we talk about the Newton's third law of motion, obviously we have already seen that there is a action and a reaction force. When a body apply any force on the body and on another body, it will also apply the same and equal force on the first body. And this law is known as the Newton's third law of motion, because Newton was the first person who just stated this. Okay, so according to Newton, according to Newton, each and every action force has an equal and opposite force. Opposite force, ब्रैकेट में रिएक्शन फोर्स. Okay. So this is the Newton's third law of motion. Newton's third law of motion is based upon Newton's third law of motion is based upon law of conservation of Law of conservation of linear momentum. Linear momentum. Okay. So this line is very important actually. Law of conservation of linear momentum. Newton's third law of motion is actually based upon the law of conservation of linear momentum. This question has already been asked in different examinations. Okay. So example, swimming. When you swim, you apply this force like this. A force is applied by your hand towards the backward, and you get the equal and opposite force in the forward direction, like this. Okay, so this is this. Okay, now another example, propulsion of rocket propulsion. Rocket propulsion, I have already explained that hot gases come out of the rocket with a very huge backward force. Okay, and this force is known as action force, and due to this action, rocket gets equal and opposite force, and this is known as reaction. This is known as reaction. Good afternoon, Nikki. Nikki, where are you from? Nikki, where are you from? I teach here on this channel, at this channel, daily at 2 p.m. Just join my session so that you can learn the physics concepts in a very unique manner. Okay, in a very simple way. I try to teach the each and every concept. The questions based upon these questions, on these concepts are asked in different examinations. Okay, so this is the rocket propulsion example. Rocket propulsion, and suppose that walking on road. Okay, when we move on the road, when we walk on the road like this, okay, we apply a force on the earth in this direction, and this is action. We get the equal and opposite force in this direction. This is reaction, and this is action, and this is reaction. Okay, so this is this, and this is the third example of Newton's third law of motion. Okay, Meghalaya, that's great, Nikki. Meghalaya is a state. Will you please tell me your district name? Where are you actually from? Watch my both the sessions. I have already completed one lecture. I have already taken yesterday, and you can watch my today's lecture also. I have taught the Newton's laws of motion. I'm sure that you have also gone through the Newton's laws of motion in your school days. Okay, but right now, if you are preparing for any examination, then obviously you will get some questions based upon the Newton's laws of motion. It means force. Okay, here we have discussed about the force and the effects of force. Okay, so guys, these are the Newton's laws of motion: first law of motion, second law of motion, and third law of motion. In the next lecture, we will do some numerical problems on the Newton's laws of motion. First of all, I will give you some questions on Newton's second law of motion, and I will give you some questions based upon the first law of motion and third law of motion. A variety of questions can be formed by the Newton's third law of motion, because Newton's third law of motion is very wide, and many questions I have already solved on the Newton's third law of motion. The major part of the numerical problems they just come from the Newton's third law of motion in other different examinations like NEET and IIT. But in case of government jobs exams, few questions are asked. Okay, and those few questions are from the Newton's third law of motion and second law of motion. It means whenever talk about the numerical problems actually. Okay. Nikki, you can, yeah. I'm from West Jantia Hill District. Great. This course is for SSC. Yeah, you can watch this lecture because the same concepts, the same questions are asked in SSC also. Okay. So I take the two sessions. One session in morning at 10 a.m. I discuss the questions, multiple choice questions for SSC exams in the at 10 a.m. in the morning, and I just come live at 2 p.m. daily to describe the theory concepts. Okay, so you will have to attend both the classes. 10 a.m. question answer session, 2 p.m. theory session, and just don't never come with only your mobile phone. Just sit on your chair and just arrange a pen and notebook. Okay, whatever I write here, whatever I teach here, you will have to note it down in your notes serial wise. Okay, and then you will have to make a separate notebook for objective questions I discuss early in the morning. I mean, I discuss at 10 a.m. in the morning daily. Okay, when you will go for the exam, at the time of your exam, you will have to revise those questions like this, like this. Each and every concept will be revised in your mind because you have already watched my all the lectures and you have already noted it down in your own language also. Okay, so I'm sure that you will achieve your aim if you will attend all the classes of all the faculties here. These are very experienced and very knowledgeable faculties of Delhi. Okay, here we are live from Delhi, the heart of the nation. Okay, so is it clear? Is it clear to all of you? Is it clear to all of you? Is there any doubt? If you have any question, any query, you can ask me. I'm here to assist you. And my name is Kumar Ravi. Right now, there are many people who are watching me live at this time. Please tell me your name and district name, state name. If you are outside the Delhi NCR area, you can write me your name, your district name, your state name, so that I can also know that you people are just getting my all the points. Okay. So these are the basic etiquettes to learn from the online free YouTube channel. Okay, Exampur is a very big platform for the government jobs aspirants, and this is a very famous among all the students. We provide them different types of classes to all the students all over India. Actually, recently we were teaching in the Hindi medium only, but the most of the students, they inquired about the English medium background, English medium classes, because they could not understand the Hindi very well. That's why they were asking for the English medium batches, and we just planned it and then we have launched it just for you, so that you guys sitting at the different locations all over India, either Mumbai or Northeast or any western part of the India. Okay, those people who can't understand the Hindi very well, they can also get your classes, study. You can also study all the subjects, all the concepts of for the government jobs examinations in your own language, and a very common language is English. Okay, and a student sitting in UP, he can also understand English. And a student sitting at the West Bengal, he can also understand in English. A student from Maharashtra, Kerala, and Tamil Nadu, Meghalaya, Tripura, everyone can understand English. Okay, so this is a very common language nowadays, That's why I'm just saying that you just have to share these videos among your friends, your relatives, so that a very big, a very huge crowd can come here and get the benefit, as well as you can make your competitors also, so that you can improve yourself. You can improve yourself, because if you will compete among two or three students, then you will not get your actual evaluation. When you will compete among the thousands of students, then obviously you will evaluate yourself very good. Okay, your evaluation will be a very good. Okay, that's why share these videos among all your friends and just join these video sessions daily at regular basis, and make your notes and revise those notes daily before sleeping. Okay, remember and just note down, my time is 10 a.m. in the morning and 2 p.m. in the afternoon. Okay, so this is over for today. We have completed the Newton's laws of motion. Tomorrow onwards, we will also solve the questions based upon the Newton's laws of motion. Okay. So thank you so much. Have a nice day. Bye bye. Take care.